Okay, this is example 4. Find the value of each variable. Write your answer in simplest radical form. So this is the first part. And we notice that it is an isosceles right triangle. So it's a 45, 45, 90. So 45 degrees, 45 degrees. Okay? And if we use the rule, this is a root 2, which means 7 equals a root 2. And x and y are the same, which isn't surprising. That's why it's an isosceles right triangle. So we go 7 equals a times the square root of 2. So in order to get a by itself, there's a timesing by root 2. So I'm going to divide by root 2. Divide by root 2, and I get a equals 7 divided by the square root of 2. Well, that's not in simplified radical form, so we'll just do that here. Multiply by a fancy version of 1. It's called root 2 over 2. And so we get a equals 7 root 2 divided by root 2 on the bottom here. Root 2 times root 2 is the square root of 4, which is a normal 2. So I'm going to write that. Okay? And there is my answer for x and y. X equals y equals, and there's the answer right there. Hopefully that makes sense. So I'm going to give you a few seconds. You should pause it if you need to write this down, and then we'll start the next part 2 of it. Okay, in this problem is part 2 of example 4, and we're trying to find x and y. Now, when I say, I'm going to tell you the answer right away. It can't be done, and you're going to go, why can't it be done? Aren't these 45, 45? So you're thinking this is 45. You're thinking this is 45. So we've got that, and then it's a square, so y is 9. But it's actually not a square. We do not have any information here that tells us that the sides are congruent in any way. It appears to be in the drawing, and so if we can assume it's drawn to scale, then it's a fine thing going on. Otherwise, it's a rectangle, and then it doesn't necessarily make 45, 45, 90. So I'm going to make one assumption here. So if you run into something like this and you want to use it, do this with your, make an assumption here, like assume that all sides are congruent as they appear to be in the picture. If you say that and you get some answers, then it makes sense. But right now, there is technically not enough information. So we'll assume it's drawn to scale. So we're going to assume that this equals this equals this equals this. And remember, one of the tricks is to give you a square, and then you put the diagonal in, and you get a 42, 45, 45. Okay? So we now know y is 9 with that assumption. If we use this assumption, y is 9. And if we go with our rule, this is a, and x is a root 2. So that means x is whatever a is, and a is whatever y is. So x is 9 root 2. There's your 2 answers. So if you need to, you can pause it and write it down. Okay, this is the third part of example 4. And again, it looks like a 45, 45, 90. So we write down our rules in here. Across from 45 is a. Across from the other 45 is a. And x is a root 2. So we can figure out x because x is whatever a is. A happens to be 9 root 2. But then you also have to multiply by this root 2. We've got this here from here. So we're going to get another root 2 here. So this is going to be x equals 9. Root 2 times root 2 is a normal 2. So x equals 18. Okay, again, following our square root rules, we're fine. That's it. We'll go on to example 5 in a second.